All right, we're back with another This Week in Cassandra. This week we have with us Ryan Spila from DataStax. He has seen about 500 great clusters and maybe 500 broken clusters. Not really sure if that ratio is correct, but he's seen a lot of clusters in his life. He's going to be talking with us today about some common anti-patterns and things that people just constantly seem to do wrong, which is a really good time. Ryan, thank you for joining us. It's nice to have you.
Thanks for having me. Appreciate it.
We also have Luke Tillman and Jui Hai, also DataStax. So it's a DataStax crew today. Not a bad time, you know. We're people too, so we get to talk. So first, big news in the Cassandra community. I got my first haircut of the year. Just want to, there were lots of rumors leading up to it. It's confirmed. The hair has been cut. Just everybody can relax now. But also, we have the Cassandra 3.5 release, which has just gone out. This is a pretty cool release. Juihai was, well, actually, you were just talking about it a few minutes ago. Juihai,
yeah.
What's your opinion on the 3.5 release?
Well, actually, they are really for the 3.0 branch. We have only 4 bug fixes, but most of them are critical. In fact, 2 of them are critical bug fixes for SASE. One of them is about SASE going OOM if you have 2 big SS tables. And the second one is like a really, really nasty index corruption. So if you are planning to use SASE, please use 3.5 and not 3.4.
And you did a lot of testing for on 3.4,
in fact, the index corruption bug, in fact, before seeing it, like I need to fetch like 20 million rows out of Cassandra using SASE before seeing the first exception. So it's really, really, really nasty bug and really hard to find.
So how did you find it? What were you testing on?
Well, the idea was if I want to full scan, not really full scan, but like fetch a third of my table out of Cassandra into Spark for analytics, right? It is an analytics scenario, so I want to use SASE to filter down a little bit of my data, and this is how it works. So I'm just fetching out of the data.
Okay. I thought you were loading up like. How many billions of rows did you put in?
Originally, I was loading up like up to 3 billions and 200 million rows.
Okay.
So the cluster was like 13 bare metal machines with SSD and lots of RAMs and lots of CPU. Perfect.
You didn't put it on a SAN?
No. Don't even talk about SAN with me.
Nice.
But hopefully now we have something stable, and at least I have tested it on like 1 billion rows. So
yep.
We never know. It may have another nasty bugs, but at least for now, with this amount of data, it does work.
Cool. Awesome stuff that works. I like it.
Yeah.
Very, very cool. So 3.5. We talked about this before. The odd, if you can tell what kind of release it is by the number at the end. If it's an odd number, it's a bug fix release. So 3.5 is just bug fixes. There were no new features. So if you're sort of like bleeding edge, but you don't want to be like as bleeding edge as Rehigh, maybe, you should think about rolling out odd releases. Maybe if you don't care, maybe you're more like Luke, and you're like, I'll just put anything into production. I don't even care if it's been tested by anybody. Just go for it. You're more of like a free spirit. Then you could put 3.4 or perhaps 3.6 when it comes out. Right, Luke?
Good advice, John.
Thank you. So the next thing that we had, there was a blog post on Planet Cassandra that I want to talk about, going multi-DC. This is an interesting blog post because it kind of talks. This guy wrote his own. What term am I?
Load balancer.
Load balancer, thank you.
Load balancing policy, actually, I guess, to be technical. But
Yeah, its own load balancing policy for this thing. So Ryan, we were talking a little bit about this before. Like, kind of, what's your take on this?
Well, so this is actually really often requested in pre-sales and support where I've worked in my different times of data stacks, and the problem with it is a lot of people that want it don't actually want it. And so, like, I think there's some valid use cases for it where people are saying, okay, we can handle the latency. We want to have a local quorum, and we're okay with having some temporary inconsistency. Because when you have like let's say you're doing local quorum reads and writes, which is sort of where this kicks in, is like if you're trying to pin to a DC and you want to fail over to another DC. The problem with that, if you're using local, it sort of implies you have a local quorum. It implies you have a strong consistency need. You're saying maybe I have 3 replicas, and I at most want to have one of the. I always want to generally get the right answer. Maybe there's a race condition, maybe a millisecond, but I always want to get the right answer. And so where this sort of thought process, at least I find people are surprised by, is if you have a transient failure. And let's say that you fail to write to your local data center, maybe one of your replicas or 2 of your replicas were down, you're going to fail over to that remote data center. Mm-hmm. But now you have this extra latency, maybe you don't hit your SLAs, and depending on the way you've written your load balancing policy, you might try again with that local one. Now your writes might have succeeded with the remote one, but not the local one, and now you're inconsistent.
Yeah.
So this is where a lot of people that do this actually don't like the result in the end. They don't like the extra latency that they get when they fail over. And mm-hmm. 2, it doesn't cover a lot of the common modes that occur. So you end up in this sort of anti-Goldilocks world where you are too slow to satisfy your SLAs, and you're too inconsistent to satisfy your implied contract. Mm-hmm. And so it only works for the cases where you have like an outage, a Cassandra cluster, and your app servers are still up, which is uncommon.
Yeah.
By our design.
But even if you had that scenario, let's suppose you were to, like, the alternative is to fail over to another DC entirely and just say, even though my app servers are up, it doesn't matter. Like, if you had to go around the world, for instance, and let's say you did, like, 50 queries, and some of them actually depended on the previous queries,
yep.
Well, then you'd end up with a situation where you added latency to each round trip of queries, right?
Bingo.
So,
yep.
Yeah, so you might as well just fail over to the entire DC is what you're saying.
Yeah, because your app servers are talking to n number of Cassandra nodes. And so now you're going over particularly a constrained pipe and sending all that data over. And if you've thought about that and you've sized for that, there's no problem with it. Like I have customers that have over 10 gig links between data centers. Mm-hmm. They're actually close to each other. They're actually just different failure zones. And so they have the latency where they can go, okay, all of these app servers are going to talk to this other data center, and that's fine. And that's completely acceptable. But most people that do this haven't thought through that. And it's one of these running with scissors type processes. Just because you can do it doesn't mean it's a good idea.
Yeah.
And so you definitely really want to be careful, and you want to think about, all right, what happens in the case of transient outages? Can I handle having a write succeed in one data center, and then my next read is going to another data center where that write may not have actually gotten to yet?
Yeah.
So you can really get yourself into some prizes where you've lost that nice warm blanket of local quorum, and you've potentially introduced some invariants, and you've broken some invariants in your app without realizing it.
Yeah. So that you hit an interesting point a little bit earlier. There was you talked about having the 10 gig link. I think one of the interesting things that a lot of people find confusing is kind of the difference between bandwidth and latency, right? People frequently, like, you could have a 10,000 gigabit connection, but the distance between your data centers, you're just fundamentally limited by the speed of light there, right?
Yeah, So there's two points though. So in practice, not only is link speed exactly what you're talking about, throughput and latency are not necessarily related. In fact, sadly, as you get further apart, oftentimes it means you maybe only have 155 meg link. Mm-hmm. So not only do you have the electrons are traveling slower, so you have to pay a 300 millisecond penalty between here and London, I think it is, and there's not really much you can do about it. But you might have only have 155 meg link between those two regions, mm-hmm. And so now you're sending maybe 3 gigabytes of traffic across it, constraining the pipe, making that already bad latency many times worse. And so instead of 300 milliseconds, you're now taking 10-second latency hit because you've constrained that pipe, and now everything breaks.
Yep.
Backup hints, all that fun stuff.
Yep. That's it's a common mistake people make. Just, oh, I have this huge connection. It's like,
yeah,
dude, you're not breaking physics. Like,
so yeah, bingo. And I'm not saying this is a bad idea. I'm saying you have to think about all the other things.
Yep.
So.
Commonly misunderstood.
Luke, any thoughts?
I was going to say that I think he kind of points out in this article too. If you're listening to this and you go and you check out the article on Planet Cassandra, he does kind of point out the different ways that you can fail over. So as opposed to doing this sort of round robin, this DC aware kind of failover policy in the driver, he does talk about failing over basically the entire data center and uses Netflix. I mean, we love to use Netflix as the example of of all things Cassandra, but yeah, he totally uses Netflix and talks about failing over at the app level. And I think the point that Ryan made is important, because a lot of times the reason that people are doing multi-data center Cassandra in the first place is because they want either disaster recovery, kind of scenario, or they want to get the data closer for better latencies, better customer experience, essentially, right? They want their clients that are in Europe to get, like low latency, good experience with their site. And so, this idea of having like, your European data center potentially spewing all these queries over to your, U.S. East data center, you're essentially going to make the latency worse and kind of defeat the purpose, of why you did it, why you went multi-DC in the first place. So, interesting read. Definitely recommend checking out the article.
Yep. Right on. So this is kind of an interesting segue for us. One of the really cool parts about having you on, Ryan, is we get to talk about the other ways in which people have tried to do things and either succeeded, or I think you've seen a lot of the failure. I mean, you've been basically you handled you were a solution architect for a long time. Now you're doing a lot of support and really kind of helping people through problems that they see
in production.
Yeah, in production. So it's kind of cool to look at more of like a macro scale of just the things that people frequently do wrong. So you were kind of talking to us earlier about the issues with let's say the load balancing policy. People think they want this load balancing policy, which will just all of a sudden start connecting to a remote DC, and then it kind of breaks the contracts that they've set up and the assumptions that they've made. And so what are some other things that you've kind of seen people do? Basically, what patterns have people led to oh, this is logically the thing that I want, and it turns out it's the exact wrong thing.
Yeah, where your mitigation strategy creates the problem you're trying to prevent. Yeah,
exactly.
So common ones are too aggressive of a consistency level. Ironically, creates, by aggressive I mean if I did every read and write at CL all, I'd be much more likely to have partially succeeded reads and writes, and therefore much less likely to actually satisfy my consistency levels because my servers are down. And so you have an ironic situation where, in the aspect of I'm really afraid of inconsistency, I've created potentially more inconsistency because now I have a bunch of nodes offline. And so now I have to make sure I haven't lost data and all these other things that I might have invented as problems in the process.
Yeah.
That one is not as common as people doing quorum or each quorum more often than they probably intend to for their use case. So that's really common. And generally misunderstandings of C levels. And one very common manifestation of that is the downgrading consistency retry policy, where people will have a very aggressive initial retry policy, and then of course it'll fall back all the way to 1, which
never understood that.
yeah, and actually I've had some really good debates with really smart people defending that, and I respect it, and I think if you understand the nuance, and I don't want to tell people not to run with scissors, if you know what you're doing and you're okay with the 1 and you're whatever, but it's sort of a transient failure. of this lower consistency, this lower policy, and so you wouldn't know about it without, some sort of logging, right? You'd have to add something to the policy to actually know that you've basically been doing CL1 over and over and over again, and you may not notice that for some time, and so that's a surprise for people.
And it confuses me because it's like if you're going to fall back to 1, I mean, it implies at some level you're okay with 1. So why don't you just use 1 in the first place? Like, why?
So I will defend a few cases of downgrading.
This is the guy I've actually had the strongest argument with.
There is a case for it, and if you have a system where, like, I worked for a company where we were doing some analytics, basically, right? And we would we tried our best to have the information be really, really accurate, but there were times where, like, maybe there was a problem. So we would rather show a page to someone with a result and a thing that says, like, warning, like, this may not be totally correct, but here's something anyway.
And so I think that would be a great idea if you had some sort of bit of data that was tracked of downgrading. Consistency policy took it to another level and said these reads and writes were 1. You see what I'm saying?
We do have this in the Java driver. You can get the execution info back, and you have the query consistency level and achieve consistency level. Yes, and you can get this information back, definitely.
But you have to log that and make that part of your app to get the benefit.
Yes, yeah, that's the case. Not just like oh, whatever. Like, no, if you're comfortable with being like, yeah, I downgraded to 1 and, like, I don't need to tell anybody. Like, if you feel like you don't actually need to tell people, then you probably could have used 1 in the first place. Like, I completely agree with you.
Yeah.
But that's the nuance, right? It's like,
I agree.
if it doesn't matter enough to actually tell the person that did the request, then it probably doesn't matter ever. And you might as well code your app against that logic and at least, like, have that in your brain while you're writing, as opposed to, like, writing under the naive assumption that you'll have quorum and then be like, oh, I'll just whatever.
Yeah, so that's actually a relatively common one. I see people go from quorum to downgrading consistency retry policy and are really surprised when they get the result. And a good example of this was I've seen people doing important things like OFAC check with downgrading consistency retry policy, which, for those of you who don't know, that's a fraud check, and there's massive fines attached to getting the wrong answer. And they had no idea. Well, but they're like, well, this in case the one node is down. And I'm like, we have nodes down, but you don't want to give the wrong answer. No, I mean, you have to, like, just be honest with yourself about what a consistency level means at some point.
Right.
And so if you're going to use something like any database that accepts multiple writes, whether that's in a global data center sense or in because this applies to whether you're using MySQL or Oracle and you're using multi-data center replication. You have multiple sources of truth. As soon as you have that, you have to be aware of that inconsistency in your read path, and you can't just naively fall over if this is really important that you get the right answer if those writes haven't replicated across.
Yeah.
Right. Anyway, so this is sort of the same idea with downgrading. So that's a very common one.
So let me ask you a question about that. So if you don't give an answer, let's suppose you're just like, I don't know, is that worse than giving the wrong answer?
Depends on the use case. For OFAC, yes.
Okay.
I mean, like, you're better off saying, I don't know the answer right now, please try again. If you can just say failed is better than.
So that's an example of where you'd rather have lower availability than something that's a few milliseconds out of date.
Yes, in fact, they should have been using lightweight transactions, actually, and that's a use case where you should. Locking mechanisms, another case you should use lightweight transactions and not like a downgrading consistency retry policy. But I mean, this stuff is common because it sounds good. It sounds like, oh, I want to be really available. This is why I picked Cassandra in the first place. It's very seductive.
Yep.
And I've had multiple people say we can't use consistency level 1 because it's too important, but we have to use downgrading consistency retry policy.
Yeah,
it's multiple people say that, and it's a logical incongruity.
Yep, there's definitely a gap in the the thought process there.
So what did you want to talk about? Any of the other ones, like division sizes or a repair not being mandatory, or I mean, there's a whole bunch of them.
Well, I think, I mean, that the repair one is a really interesting one because I think people frequently say, I don't do deletes, so I never need to repair. Just to throw that out there. I've actually seen that many times. I don't do deletes, so I never need to repair.
I've actually heard it gone further than that. Well, we haven't had any problems, so we don't need to run repair.
Oh, it's like,
and they are doing deletes.
Yeah, that's. I mean, the delete. Okay, the deletes are an interesting one because obviously you can have zombie data, right? Like we need to get those tombstones in place before the GC grace seconds, right?
Yeah.
But there are absolutely cases where you need to do repair, even if you've never issued a delete. Have you worked with people who have just been like, whatever?
Oh yeah, no, I would say probably 30% of new users to Cassandra don't think they ever need to run repair. That I've worked with, at least, and I have to convince them that they need to.
My next question was going to be, would you say that is wrong?
Yeah, so I actually did a blog post about it called Cassandra repair should be called mandatory maintenance, and instead of like no tool mandatory maintenance or something like that, or like a warning should go in the logs, you haven't run repair in X, Y, and Z. Because it's just a very common thing. And I think a lot of people come from a background where you don't have to run this sort of operation on the database, and I can see the argument for. Because of the nature of where Cassandra is such a mind shift, I could see the argument for maybe it's something we should be handling on our own. Maybe it's part of a server process. But.
Yeah,
so there is a cure for that.
Yeah, does anybody know why we haven't like made that sort of like compaction where it runs in the background as sort of a
There is a cure for that.
It's an epic. It's an epic, like so many Jira attached to. Because it's quite complex because a repair operation is very, very intensive, network intensive, and this I/O intensive, CPU intensive. So you cannot take it lightly.
Yeah, you'd have to have a lot of throttling, like we do with compaction, really. Where people overtune compaction, or they make too much of the node a compaction engine that it has nothing left to do anything else. Like my all-time favorite, unthrottled compaction, which people will use to get out of a problem, but a lot of customers run that as their normal default compaction throughput setting is unthrottled, and then they'll submit a ticket for why do I have bouncing latency. So this is really common, but again. You have to remember the historical, like sometimes I sound like I'm being like hard on people, but this is all new, this is all complicated. We'd have 30 years of third normal form training and different strategies with databases that now we're telling people the opposite thing of. And they haven't had to think about compaction in the same way that we now just have to for them, and tuning is not ideal. We need some more auto-tuning in Cassandra, I think, to make this something that they don't have to get wrong. So compaction's really tough for people to tune correctly. I see people crank current compactors really high. That's very common. They'll have spindles and they'll have 48 cores and they'll have concurrent compactors at like 48. And their 7200 RPM hard drives will be dying and spindles going everywhere.
Well, even in the Cassandra world or just the tech world in general, like enough has changed in the last 5 years. Like let's forget about the last 30 years. The advice that you may have gotten 5 years ago or 3 years ago about let's say JVM tuning may be completely different right now. For instance, if all the advice that everybody gave out 2 years ago about tuning the JVM for let's say write heavy workloads is horrible if you have a read heavy workload on solid state drive. It will destroy your cluster, and that's what we found at my last company. We put out one of the first posts on how to tune for read heavy workloads, and we were doing it on solid state drives. And
what was the difference? What was the difference?
Because you need a really big new gen size if you want to do read heavy workloads, because you have a lot of these short-lived objects. And if your new gen's too small, then they get promoted prematurely, and you end up with a lot of full GCs because you're just constantly reading a ton of data off disk and pushing into your old gen, and then you full GC, and it's you end up with 10-minute average latency on queries,
awesome.
Which is that doesn't meet your SLA at all.
But even that advice that you guys had, like, is probably like what, a year or two old at this point.
It's really outdated now.
I mean, it's moving, so things move, especially with Cassandra, so quickly. Like with G1 GC versus some, like we've got new garbage collectors now in Java. And,
Yep.
it's like, it changes so quickly. So.
Yeah, so it's hard to keep up with it, and it's like, and you've got this distributed system, and like it's, maybe you have it spread across 500 servers, and it's just like, how does this thing behave? Like, it's just hard to understand, I think, sometimes. So, yeah, I agree. There's a lot of areas that we can do to improve these things. Like, there's a lot of auto throttling things that can happen. Yes, 100% on that. Kind of like how like you just brought up G1. G1 will auto size the number of new generation regions, old gen, survivor. Like, it will take care of everything for you. Eventually, I think that you'd probably want to see that out of your database too.
Yep. Yeah, particularly with all of our processes that are new for people. Yeah.
Yeah. The last thing I wanted to touch on with you was storage, because people, even I hit this, and I'm not dealing with people in the field as much as you are. I'm dealing with people that are new to the Cassandra world. Luke, like you and I have gotten this question a million times. Zhuihai, you've probably seen this a bunch of times. I mean, in the beginning, you were like, "Don't say SAN around me."
Yeah.
What are some of the like? What's the worst you've ever seen someone try and incorrectly put a SAN into production with Cassandra? Ryan.
Oh boy! So recently, I had a ticket where somebody had 4 nodes per VM, and they were all sharing the same LUN.
Mm-hmm.
That was pretty bad, and it's like a 72. It's 7200 RPM spindles in RAID 5 configuration.
Okay.
So that's pretty bad. The worst was I had a 6-node cluster, all sharing the same LUN, and that one was falling over heap OOM, and they were large writes too, so that made it worse. Was falling over OOM at 14 TPS.
For the whole cluster.
Whole cluster would literally just all chain offline because the disk would stop moving. It would just get frozen basically, and so then nothing could happen, and then the writes would just back up, and it would just OOM, and that was pretty amazing.
Yeah.
Large batches, super big batches, like 2 meg, 3 meg, 10 meg batches. Yeah.
Yeah. So on the that's 2 things. I wanted to make SAN the last thing.
Yeah.
So SAN, Zhuihai, what have you seen? What's some like gnarly SAN business that you've seen?
I didn't see really people using SAN because I stopped them before they use it. But I have like very interesting question, like, oh, by the way, we want to do some performance benchmark, but it's really, the results are really, really bad. So I asked them, so how did you do your performance? Oh, we pop up like 5 virtual machines, and then we start injecting data, and then just fail. Well, it's 5 virtual machines sharing the same disk. Sorry, there's no magic. Always the same issues.
It's funny, like people benchmarking on SANs. Like I think one thing that people don't know is, and this is true benchmarking Cassandra in general, is they'll run a benchmark that runs for 5 or 10 minutes or half an hour or something like that, and data never ever actually gets flushed to disk in the first place, or they don't run it long enough where compaction actually kicks in. So they kind of get this false sense of security that oh, my SAN's okay, like it seems to perform okay, and then they get it out into production, and then you've got compaction, and you've actually got stuff being flushed to disk, and like it's a whole other story. So
like trying to do a read heavy test when all of your data sits in memory.
It's
not a SAN. Like you just kind of wasted your time.
So I've actually, when I was in pre-sales, I had about 7 accounts just use a single node on SAN as their POC. Single node.
We're not going to name names. We're not naming names.
Yeah.
That's a rule.
Yeah.
Awesome. Sweet. So don't use a SAN.
Yeah, and actually test with more than 1 node. In fact, maybe 5.
Yeah. Definitely do that, and don't use a SAN. Just use dedicated disks. Just whatever. All right, I think we can wrap this one up. Ryan, appreciate having you on. Thank you very much for your time.
Thanks for having me.
Anything you want to say before we cut out?
I guess just really before anybody gets started with Cassandra, make sure that you think about things as how they have to work, not as magic or not as Cassandra's just handling it for you magically. This is a distributed database, and if you don't understand how something works, ask. Definitely ask.
Yep.
Get on the IRC. There's some really helpful people there.
Yep, mailing lists, Stack Overflow, whatever. Ask somewhere. Hit us up on Twitter.
Please.
Anywhere. Yeah. All right, cool. All right, let's wrap it up. Guys, thank you. Shut it down.